Alright, now there are some basic rules that we're going to need to be familiar with. Just like there was repeat offenders for taking derivatives, there's going to be these repeat offenders for taking integrals. Now these are the basics that we've learned throughout the term. We know that the derivative of just x is 1. Here's the power rule. And these are those trig derivatives that we became familiar with over time. So the integral is going to be the exact opposite, go in the opposite direction. So if we try to take the integral of 1, it's going to be equal to x. And don't forget that plus c. Because if we took the derivative of x plus c, we'd be left with just 1. Okay? So let's look at the power rule now. We want to take the integral of x to the n, some power. So instead of multiplying the exponent down front and then subtracting by 1, we're going to do the exact opposite. We're going to add 1 to the exponent and then divide by that new exponent. And of course don't forget your c. And the trig functions seem to get a little bit easier. It's just the exact opposite. It couldn't be more opposite. So the integral of cosine x is equal to sine x. And that trend continues all the way down. So I would strongly recommend that you become pretty familiar with this table. That way, every time you encounter these problems, you won't have to spend 15 minutes trying to figure it out. Here I give you a function f of x, and I want to find the antiderivative by thinking about the derivatives in reverse. So if I were to take the derivative of f of x and find f prime, I would take the exponent, which is 1, multiply it to the front, and then subtract 1 from the exponent. So we got 6 times x to the 0 power, which is just 1. So if I'm finding the antiderivative, if I'm finding the antiderivative, I'm going to do the exact opposite. So I'm going to add the exponent first, and I'm going to divide by the new exponent, and I'm going to simplify. And don't forget about your plus c. Okay? So if I took the derivative of this function here, if I took the derivative of this function, we would end up back up here. The derivative of 3x squared is 6x. The derivative of a constant is 0. So then that's where we left off. Okay, let's try another one. Let's think about this. Oh, this one's looking a little tricky. We got fx equals 4, secant of 3x, tangent 3x. Okay, so if I was trying to take the derivative of this, I would think, man, we might need to do a chain rule here because we have 3x inside of a function. So we would eventually have to multiply by 3 using the chain rule. So in our antiderivative, we're going to divide by 3. And the antiderivative of secant tangent, and that would be secant. So we have 4 secant of 3x divided by 3. Okay. Now if we took the derivative of this function here, we would end up back up here. So that's a little way to make sure you did it right. If you take the derivative of what you guys are in antiderivative, you should get the original function. Alright, here are a bunch of problems dealing with what we just talked about. Do your best to find the antiderivatives, so just try and match them up to the table that we wrote down earlier. Try and do one of each type at least, but if you are stumped, don't worry about it. Just come to class with the questions and we'll try and figure it out.